Uh, Hello dear students, let's study the atomic radii. As we go down the group, atomic radii increases as the number of shell increases. In a period, noble gases have their atomic radii longest. Give reason. When an atomic radii is determined, for metals, metallic radii or ionic radii, for non-metals, covalent radii are determined. But for noble gases, we determine the van der Waals radii or atomic radii because they are mostly available in their monoatomic molecular state. Van der Waals or atomic radii is always bigger than the covalent or metallic or ionic radii, so noble gases have the largest value of their atomic radii in the respective period. This is how we can understand about the atomic radii. Now we should study about the electron gain enthalpy. Since electron gain enthalpy is the amount of energy exchanged when an electron is added to the isolated gaseous atom in its ground state. So as we are going to add electron, these elements do not have any attraction for the extra electron, and that is why instead of energy is released, energy has to be provided from outside. That means the enthalpy change will be positive. And let us read about the electron gain enthalpy. Since noble gases have stable electronic configuration, they have no tendency to accept electrons, and therefore noble gases have large positive values of electron gain enthalpy. Now we should study about the physical properties of group 18 elements. All noble gases are monoatomic. They are colorless, odorless and tasteless. They are sparingly soluble in water. They have very low melting and boiling points. Please remember that they have very low melting and boiling point. So let us study why do they have very low melting and boiling point. Noble gases have very low boiling and boiling points. Why? Noble gases being monoatomic have no interatomic forces except weak dispersion forces, and therefore they are liquefied at very low temperatures. Hence, they have very low boiling points. So that is the reason why they have the very low boiling point, because they do not have any other kind of interaction among the molecules, but they have just the weak dispersion forces, and that is why they have the low melting point. Now this is very interesting. Helium has the lowest boiling point, 4.2 K of any substances. So all the substances in this world have the higher boiling point than the helium. Helium being very small in size, helium has an usual property of diffusing through most commonly used laboratory materials such as rubber, glass or plastic. My dear students, helium is available as a monoatomic molecule, whereas even hydrogen is available as a diatomic molecule. So even the diatomic molecule of hydrogen is bigger than the helium, monoatomic helium. Helium having very small size, it can even pass through the molecular gaps of these rubber, glass and plastics, and can diffuse out very easily or can creep up from this gap. And that is why helium is used for such a wonderful causes where the patients have the respiratory problems. It is an interesting property of helium. There are two special property regarding helium, that it is denser than it is lighter than air, that it can easily passes through the very small places, and it has got the lowest boiling point among all the substances available on this earth. Now we are going to, so please remember these important physical properties of helium. Now we are going to study about the chemical properties. In general, noble gases are least reactive. Their inertness to chemical reactivity is attributed to the following reason. Number one, noble gases except helium have a completely filled electronic configuration, ns2 np6. Actually helium also has got completely filled electronic configuration, but only one orbital or only one shell, that is k shell, is completely filled like 1s2. And in their valence shell they have high ionization enthalpy, more positive electron gain enthalpy, so it is difficult to remove or add electron to the inert gases atoms, and that is why they are mostly unreactive. The reactivity of noble gases have been investigated occasionally, like time to time scientists have always tried to study the reactivity of these noble gases. Helium and sometimes neon are found in minerals of the radioactive origins. So sometimes helium and neon are found into the minerals like peach blende, monazite and clevelite. The main commercial source of helium is natural gas. The main commercial source of helium is natural gas. So helium is obtained from the natural gas. Xenon and radon are the rarest element of the group. Xenon and radon, they are not much found, so they are considered as the rarest element of this group. Helium is also found in the natural gas, that is what we have seen. How do we get radon? So radon is obtained as the decay product of 226 radium. So radium, when it releases the alpha particles, we get radon. So this is how we can understand the radon. Radon has got very small half-life, that is of 3.81 days, and that is how we can understand that it has got very small lifespan. Even the compounds of radon, that is RnF2 has not been studied much. It was just observed, it was not isolated. So this is how we can really understand about these elements. Now we are going to study in detail. uh, we have seen, or we have been studying about how these elements actually have got studied their reactivity. In March 1962, Neil Bertlet at the University of British Columbia observed a reaction of noble gas. So now we'll study about their reactivity. First, Neil Bertlet prepared a compound O2 plus PtF6 minus. It was an oranged color compound. Then he realized that first ionization enthalpy of molecular oxygen was 1175 kilojoule more joule per mole. But the first ionization enthalpy of xenon was found to be 1170 kilojoule per mole. That means the electron can be easily removed from xenon as compared to the oxygen. And still, oxygen has made a compound in the form of O2 plus with PtF6 minus. That means we can even prepare the compound from xenon with PtF6 minus. The same he has done, the value are almost identical, and then Neil Bertlet made effort to make a same type of compound with xenon, and he was successful in preparing another red colored compound Xc plus and PtF6 minus by mixing xenon and PtF6, that is known as the platinum hexafluoride. Platinum hexafluoride is a very good fluorinating agent, and that is why XePtF6, an orange colored compound, was first observed. After this discovery, a number of xenon compounds have been synthesized. These xenon compounds are mostly with xenon and most electronegative elements like oxygen and fluorine. So mostly these compounds, or the compound of xenon, is possible only with the two most electronegative element. One is fluorine and another is oxygen. I hope, my dear students, you are enjoying your studies. Happy learning.